So we're supposed to use this given table to write an explicit and a recursive rule for the sequence. So first thing you want to do is you want to find your A value. What's the common difference? So looking from right to left, you're subtracting. So position 1 minus position 0, 5 minus 2 is 3. 8 minus 5 is 3. 11 minus 8 is 3. So that's our common difference. So that's our A. Because it's the same each time, it's an arithmetic sequence. So then our A value is 3. Next thing you want to do is look at your initial term. Sorry, that's not A, that's D. Sorry, D. The difference, D, is 3. Common difference is 3. The initial term is A. The initial term here is 2, and its position number is 0. So if we want to write the explicit rule, f of n is equal to initial value 2 plus the difference 3 times n. And then we want to look at what values of n we're using. That's values from 0 to 5. So then with a recursive rule, first thing you have to do is state what's your original value. So f of 0, position 0 has a value of 2. And then our rule is f of n is equal to f of n minus 1 plus 3, that difference d, for the values of n from 1 to 5. Looking at this table, first we want to check the differences of the consecutive values. So 25 minus 29 is negative 4. 21 minus 25 is negative 4. Negative 4, negative 4, negative 4, all across the board. Since the differences are the same, the sequence is arithmetic. So the initial term A, its value is 29, and its position number is 1. So as already observed, the common difference D is negative 4. So the explicit rule, f of n is equal to our original value, 29, times D, which is negative 4. This one's going to be a little different. Should be n minus 1 for n is between 1 and 6. Sorry, n should be between 2 and 6. So the recursive rule, we give the initial position f of 1 is equal to 29. F of n is equal to f of n minus 1 plus the difference, negative 4, for values between 2 and 6. All right, so if we want to write these, first thing we want to look at is the common difference between the points. Difference, if I can spell it correctly. So negative 2 minus negative 7 would be a positive 5. 3 minus negative 2 would be a positive 5. It's positive 5 as we move right to left as we go across the board. So that means our difference is 5. So our initial term is negative 7 when n is equal to 0. So our explicit function, we'd say f of n is equal to our initial term negative 7 plus our difference 5 times n for the values of n between 0 and 5, because that's what's given in our table. And then the recursive, the first thing we say is what's our original point, so f of 0, which is equal to negative 7. So then we'd say our function, so f of n is equal to f of n minus 1 plus the difference 5 for our values of n between 1 and 5, since we already stated our original position. So first thing we look for is a common difference as we move right to left. 5 minus 11 is negative 6. Negative 1 minus 5 is negative 6, so on and so forth. So that's our common difference. Our initial term is 11 when n is equal to 1. So position 1 changes things a little bit. Our f of n is going to be our initial term 11 minus 6 times n minus 1 for n values between 1 and 6. And then our recursive, we say the initial point, so f of 1 is equal to 11. So then our new function f of n is equal to f of n minus 1, the previous position, minus 6 for our difference. And then we're picking values between 2 and 6. So as we saw in the Explore, the graph consists of points that lie on a line. If we have a final term, it's a finite sequence, and its graph has a countable number of points. If it's got the dot, 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 the ellipses after there, it does not have a final term, so it's called an infinite sequence, and the graph has infinitely many points. So since we can't show the complete graph, we show as many points as the grid allows. So now we're actually going to be plugging in values into the functions and seeing what outputs we get. So our function is -1 plus 2n for values between 0 and 4. So all you do is take the function, plug in your inputs for n, and see what output you get. So when n is 0, you plug in 0, you get -1 plus 0, which equals -1. When n is 1, you plug it in, -1 plus 2, which is equal to 1, and you can graph the points just like they did there. So this one, we're given a recursive sequence. We're given our initial value is just 4. So when n is 1, our f of n, our function is valued at 4. So when you do a recursive, essentially what you do is you take whatever the previous value is and then add or subtract the difference. So for n of 2, we'll take f of 1, which was 4, and this time we subtract 0.25 because that's our difference. So we take 4 minus 0.25, which is 3.75. So for f of 3, we'll take our previous answer, 3.75, subtract the 2.25 to get 3.5. And we take 3.5 minus 0.25 to get 3.25. And then we get 3.25 minus 0.5 is 2.5. 0.25, which is equal to 3. So then the values of the sequence would be 4, 3.75, 3.5, 3.25, and 3. And then we can graph these. So 0, 4, 1, 3.75, 2, 3.5, 3, 3.25, and 4, 3. Number 5. So we're given values of n from 1 to 7. So f of 1 is equal to 8 minus 2/3 of 1 minus 1. So that's 8 minus 0, which is just 8. F of 2, take 8 minus 2/3 times 2 minus 1. Well, that's 8 minus 2/3, which should be 7 1/3. F of 3 is equal to 8 minus 2/3 times 3 minus 1. Well, that's 8 minus 4/3, which is 6 2/3. And then you'll continue doing the same process until you get to f of 7, because that's the last value. We're finite here. So you'll have 8 minus 2/3 times 7 minus 1, or 6, which is 8 minus 12/3, which would just be 4. So different values here. We can graph them. We'll end up being at 1, 8, 2, 7 1/3, 3, 6 2/3, 4, 6, 5, 5 1/3, 6, 4 2/3, and then 7, 4. So this would be the values to graph in our sequence. So working through another one. This is a recursive. We're given f of 0 is -3, so that's our starting point to start with. So f of 1, we take our last value, which would be -3, and we subtract 1. So we get -4. F of 2, we take our previous answer, -4, subtract 1 to get -5. F of 3, take our previous answer, -5, subtract 1 to get -6. Then you'll graph all these that you can on the graph: 0, -3, 1, -4, 2, -5, 3, -6, 4, -7, 5, -8, and 6, -9.